Okay, chapter 1, problem number 41 in the SOCOS textbook is asking you to find the change in velocity of an object that's moving around a circle, and they give you two velocity vectors, the final and the initial. Remember that a change in anything is final minus initial. So essentially what we're doing here is we're taking the final velocity vector and we're subtracting the initial velocity vector from it. Remember that with vectors, when you subtract two vectors, essentially what you're going to do is you're going to add the opposite of the second. So what we have here is final velocity plus the opposite of the initial velocity. And we will then add these using the tail to tip method. Here I've drawn the two vectors that I'm now adding, final velocity plus the opposite of the initial velocity. So my resultant will go from where I started to where I ended. So that's what my resulting velocity vector is going to look like when I'm looking for the change in velocity. That's what it's going to look like. So to find now the magnitude and the direction of my resultant, I just have this right triangle. I'll use the Pythagorean theorem, 10 squared plus 10 squared equals, and then add those two and take the square root. That'll give me the magnitude of my resultant, r. And then the direction, well, that's pretty simple in this case. Since both sides are equal, we know that it's just going to be 45 degrees. And we can take it even further. Remember that we start with 0 degrees here and go in a counterclockwise direction. So you could say 45 degrees south of west, but you could also say our direction would be 180 degrees plus 45 degrees to give us, what is that, 225? At 225. So 225 degrees is our direction, and our magnitude, which is 10 squared plus 10 squared, square root, will end up being 14.1 meters per second. 14. Well, my pen's not working for whatever reason. 14.1 meters per second. And there you go.